In this video, we want to introduce what's called interval notation. So interval notation is going to be used frequently throughout this course. And if you go into calculus, you'll see it also in calculus. So pre-calc 1, pre-calc 2, you'll use interval notation, and then also throughout calculus and beyond, you'll use it. So first of all, we're going to start with the set notation that we're apparently supposed to be familiar with already. Like if you take a college algebra course, you'll see the set notation. Let's say I have this curly brace here that means a set. So I'm talking about the set of all x values such that, this colon means such that x is greater than a and x is less than b. We're going to close this out with a curly brace. So this is the set of all those x values that are in between a and b. Notice that they don't include a, they don't include b, because we have the strictly less than sign and the strictly greater than sign here. If I wanted to graph this on a number line, I would take my two key numbers a and b. And imagine you have this dude called x. We don't know where x is. He's varying. He's in between a and b. So x is somewhere in here within this range of values. So x is somewhere in here. So x can be any real number between a and b, but it cannot include a because it's strictly greater than a. So what we're going to do, we're going to put an open circle. Open circle designates that you're not including a. And also we're going to put an open circle on top of b. Open circle because we're not including b. So basically, the open circle indicates that you go all the way up to a, but you don't include it. And the open circle around b indicates you go all the way up to b as far as you can, but you don't include it. Now, if you wanted to introduce this in what's called interval notation, that's what we're going to write today. The way you would write that, you would write a parentheses, and then an a, and then a comma, and then a b, and then a parentheses. So what these parentheses mean, these parentheses essentially correspond to those open circles. So a parenthesis means you're not actually including a. It means you go all the way up to a, but you don't include it. And then the parentheses around b on the right side of b indicates you basically have a circle there at b. You don't actually include b. So you go all the way up to b, but you don't include it. So parentheses are indicative of not actually including the end values. You approach them, but you don't actually include them. Okay, so we want to look at another type of interval. So this is when you have the parentheses on the left and the right. Here's another type of interval. We're going to write down the set notation first. Set of all x values such that a is less than or equal to x and x is less than or equal to b. So this is all the x values, all real numbers x that are in between a and b, but also they're going to include the endpoints a and b. Why do they include? Because you have those little partial equal to signs. So I'm going to draw a little line graph. I'm going to put down an a, that's going to be some number, b, that's going to be some number. And x is in between, we know. It's greater than a, and it's less than b. But also because we have those little partial equality signs, we're going to include a and b. And how do we designate that? Well, we fill in the circles. So we're going to have these closed circles on a and on b as well. Now to represent this interval, an interval is basically a block of numbers that are connected. We're going to put down on the left a bracket, a square bracket, and then an a, and then a comma, then a b, and then a square bracket on the right of b. So what does this square bracket indicate on the left of a? That means we're actually including a as an endpoint. And what does the square bracket on the right of b indicate? Well, it indicates we're including b as a right endpoint. So brackets, the square ones, the square brackets indicate you're including the endpoints. The parentheses indicate you're not actually including those endpoints. You never reach them. Okay, so let's do another interval, another type you might see. set of all x values such that x is greater than a and less than or equal to b. So it's all the real numbers that are greater than a and less than or equal to b. So everything that's between a and b does not include the left endpoint a, but does include the right endpoint b. So if we wanted to graph that on a line graph, that interval, we plop down a, plop down b, we'd shade in between because we know x is in between a and b, but on the left, we have an open circle, we're not including a, and on the right, we put a closed circle because we're including b. That partial equality sign on the right includes b. So in interval notation, we'd put down parentheses, a, comma, b, bracket. Parentheses on the left means we're not including a, bracket on the right indicates we're including b. Okay, let's do another example, or another type, I should say, another type of interval, a set of all x values where x is greater than or equal to a, and x is strictly less than b. So we're talking about all the real numbers x that are between a and b, include a, but do not include b. So for a line graph interval, we put down a, we put down b, and we shade in between those. On this one, we're going to include a on the left. So we're going to shade in a closed circle for a, and for b, we're going to put an open circle since we're not including b. That should be an open circle there. All right, so for our interval notation, we're going to put a bracket, a, that means we're including a, and then a b, and then a parentheses, meaning we're not including b. Okay, so these are all the, what are called the finite intervals, all the different types of finite intervals. That means they're they don't continue on forever. They don't continue on forever, like to the left or to the right. So these are finite intervals. We have some other intervals that are called infinite intervals. It means they go on in one direction, possibly, or maybe both directions. So the next one I'm going to give is, in set notation, you write this interval as the set of all x, such that x is strictly greater than a. So I'm writing a line graph. There's really only one important number here, which is a. So we're looking at all those numbers x, such that x is greater than a. So where is x greater than a? Well, to the right of a, x is greater, so over here. So x is somewhere down here on the right. Do we actually include a? Do we include a? No, we don't, so we're going to put an open circle. Why don't we include a? Because x is strictly greater than a. Now, if you imagine this concept of infinity, now infinity is the idea that you just keep going to the right forever. If you imagine this concept of infinity being way far to the right, and you never actually reach infinity, right? You never get there to infinity. It's impossible to get to infinity, but it's kind of a boundary to the right, if you can imagine that. Then if you're writing your interval notation, you start on the left boundary, which is a, and we put a parentheses around it. So parentheses a, why parentheses? Because, well, we don't include a, right? And then on the right, we're going to think of infinity as our boundary. And because we never actually reach infinity, we keep going and keep going and keep going and keep going forever to the right and never reach infinity, we're going to put a parentheses. Remember, parentheses means you don't actually reach that value, you actually don't land on that value. It's not included. So you're trying to get to infinity, but you never get there, so we put a parentheses on the right. Okay, so here's another type of interval. You'll see, let's say we have the set notation, the set of all x values, such that x is greater than or equal to a. Well, this one's quite similar to the last one. I'm going to do our line graph. So we have one important number, a, we're going to plop down. And remember that we're talking about all the numbers x that are greater than or equal to a. So if we're talking about greater than a, then we're to the right of a. So x is somewhere here to the right, or it could be equal to a. If x is equal to a, then we're going to shade in the closed dot on top of a. Now to the right, you have this concept of infinity that you're never going to reach. So if I wanted to write down the interval notation for this, I'd start with an a, and I put a bracket in front of it. Why a bracket? Because you're actually including a. And then a comma, and then an infinity. Then after the infinity, you're going to put a parenthesis because you never will reach infinity. You're trying to get there, but you'll never reach it. So we put a parenthesis after the infinity. Okay, so these are two types of infinite intervals. We can do a couple more infinite intervals. Actually, 3 more. So here's another one. Set of all x where x is less than b. And b is a number. If I put down the line graph, I'll put down the important number of b. Notice we're talking about all numbers x that are less than b. So less than b means to the left here of b. And since we're strictly less than b, we don't include b, we put an open circle on top of b. Now imagine to the far left, as you go to the far left, you have this concept of negative infinity that you're trying to reach, but you never reach there. So if I wanted to write down a interval notation, I write negative infinity first. I put a parenthesis in front of that. Why a parenthesis? Because you actually never reach negative infinity on the left. So when you never reach something, you're going to put the parenthesis. Then we're going to put a comma, and then b. And then after the b, we're going to put a parenthesis because we never reach the b, right? We don't include b. Okay, let's do another one similar to that. Let's do the set of all x such that x is less than or equal to b. So we're going to make a number line here to line graph this interval. So we have b as our important number. And on the left, we're going to shade because x is less than b. But also x is equal to b. So we're going to include b by making a closed circle. And then imagine there's a negative infinity that you're trying to reach as you go to the left. You never reach it. So for an interval notation, we'll write parenthesis, negative infinity, because we never reach the negative infinity, then a comma, then a b. And then instead of a parenthesis, we're going to put a bracket on the right of b. Why a bracket? Because we have an open circle, a closed circle on top of b, right? We're including b. So since we actually land on b, we include b. We put the bracket. Okay, so there are 4 types of infinite intervals that go on just on one side. The first 2 went on to the right forever. The second 2 went on to the left forever. And here's our last type of interval that you encounter. That's what intervals that go in both directions. So let's say I just have this, that symbol there, that R with the double bar on the left side. That's called the blackboard R, or some people write it like this. I usually write it like this though. So you put it's like a rectangle, then you draw an R. So this is called the set of all real numbers. This is equal to the set of all real numbers. That's what that means, all real numbers. It's the set of all real numbers. So if you were to graph this on a number line, it would be all the numbers on the number line. So all the way to the left, all the way to the right. So imagine on the right, you have this infinity, and on the left, you have this negative infinity that you never reach. So you're going all the way to the left as far as you can, all the way to the right as far as you can, and then you just keep going on both sides. So for an interval notation, I'm going to put a parentheses, negative infinity, comma, positive infinity, parentheses. So the parentheses are to indicate that you never actually reach the negative infinity or the positive. So these are all the types of intervals that you encounter. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 types of intervals. I want you to become familiar with interval notation. We'll be using it a lot in the future.